So welcome to my session on AI and ML in the Azure Data Platform from Microsoft, Azure technology from Microsoft. My name is Armando Lacerda right here, and that's kind of a mirror thing. I point that way and it's pointing this way. It's going to be fun. You're going to have fun throughout this presentation. It's going to be pointing things all wrong all the time. In any case, my name is Armando Lacerda. I am a data platform professional. I started as a developer over 30 years ago, and I switched to the data portion of the specialized data processing side of things back when I was working with IBM and my mainframes, then Oracle, and then back in 1997, 98, I switched to SQL Server 7.0. And I've been seduced by the dark side of the force, been working with SQL Server since then, and it's been a great career. I'm also a Microsoft MVP, which is an award that Microsoft gives to people who likes to do things like this that I'm doing here right now. Microsoft recognizes people who excels in their skills and also share with other people what they know about Microsoft technologies, some other open source technologies too, since Azure is embracing more technologies than just proprietary Microsoft ones. So it's something you should consider, right? Next time around that SQL.LA is going around, submit a session and present like we're doing here, and you can get noticed and you can get awarded. I'm also Microsoft MCT, which stands for Certified Trainer. I've been training Microsoft classes, official classes, for over 25 years, and it's been also super cool. I would love for you to connect with me on social media. I have a LinkedIn account. It's Armando-Lacerda, and you can also find me on Twitter. I don't tweet much. I usually post more on LinkedIn. But yeah, you are welcome to connect. It will be a great pleasure. I gotta see pointed wrong again. I got a couple of I have a few certifications. I'm about 200 certifications, and the reason I have so many certifications just because as a trainer you have to get certified in order to deliver a class. So I end up collecting a lot of certifications. But at the beginning it was kind of scary. Over time it became kind of a fun thing, and the benefit of a certification is actually the preparation for the exam. You learn a lot and expand your horizons a lot. So I highly recommend you to take a look in that. And that's how I got into AI and ML, because when working with SQL from all the way back in the past, AI and ML were kind of a futuristic thing, kind of from movies, from Hollywood and these things. But then in the cloud, when we got scalability and all of the things that are allowed in the cloud, and the compute capacity are allowed in the cloud, these things got way together, way more close to each other. And Microsoft, as a vendor, they started like, we're going to have data and AI on the same subject, on the same bucket. And as I was preparing to get certified, the new features and the new things on SQL Server, especially in the cloud, AI jumped right in. And my development side of me came also along and say, hey, we got something new to try on source code. And then is when I started getting into AI and ML. I ended up getting a little off track from the data platform and went to MIT class on data science, because this things a lot to do with data science too, and I got into there. Took that short class there, non-accredited though, but short class there, 8 weeks actually, and it was fun. I highly recommend that class from MIT if you want to dive deep into this. So this particular session, I put it together because of my work. I work not just as a trainer but also as a consultant, and sometimes when you get into meetings with customers, the customers, they don't have, some people, they don't have the accurate perspective of how AI and ML work, what's the difference between these two things. It's actually kind of interchangeable depending what setting or context you are in. So the goal of this, when I first developed this session, was for the consulting company I work for, which is Intellect, by the way, down there in Atlanta, Georgia. They're great guys, great group of people. So I put this together in order to present for our customers, so we can understand from the Microsoft platform, from Azure platform, how these names are used and when to use what, and how we can deliver AI into the multiple data services there are there. So this is a kind of a one-on-one kind of session, and there will be some PowerPoints in here, but also some demos for you to grasp the content and the approach that comes from Microsoft on this. And my clicker is not working, so I have to stretch out here, and I think I have to click. There's my mouse. There we go. So now it will work. Perfect. Yeah. So this is our agenda for the next 45 minutes. We're going to go over the whole idea of AI, ML, and cognitive services in Azure. Then we're going to see how we develop custom AI models, and then how we can get this models to process our data and to work together with our data. As a consultant, and when I get into clients, I usually get clients confused about how they leverage ML, and how ML really works and how ML is developed. So they go out, and when they start looking into ML and cognitive service, they go out and they see diagrams like this. So here, I'm pointing wrong again, diagrams like this. So this particular one is one of the many there are out there in the Azure Architecture Reference. So if you Google it, if you Bing it, you're going to see Azure Architecture Reference site from Microsoft, and you're going to find a bunch of models in there, a bunch of designs in there, and this is one of them. And in this particular design here, what you see and what I want to call your attention to, and again, I'm going to use this thing here. I have to change it to the laser point. Let's see if the laser point goes. There we go. What you're going to see here is, you have data coming from streams, and there is an Azure function processing that data. And this is a kind of a regular pipeline, low profile pipeline. It's Azure functions doing something, or probably formatting and storing the data into a database, in this case, MySQL, and Power BI is consuming from there. What I want to call your attention here too is these two pieces, right? You have here cognitive services, and you have here machine learning service. So what are these two things doing around here? Are they the same? This is all about AI, right? Are they the same? Well, I'm going to go into more details on that on the next one, but one of the things to keep in mind here is this is somewhat predefined statistical models to work with whatever data you present to them. So there is a code here in Azure Function that's calling a REST API endpoint that's doing the inferences on the data and returning the results. Whatever inferences you want to do, you're going to get more details in the cognitive service. So this is pre-packed. It's something that someone has already created. This someone is Microsoft and their team. While this one here is something that was created by the company, whoever is adopting this architecture itself. So the company, the business has created their own machine learning model to process the data and apply inferences. So when you see an architecture like that, you're like, so this one is to be used with the database only, and this one with Azure Functions only. Of course not, right? But the point in here is this can be interchangeable, and there are different levels of engagement to get things ready and working depending on what you do. And what is missing on this architecture here is this guy will work in here if there is some compute going on, right? Like Azure Functions, the compute in here, there must be a compute in here going on too to get the data in the MySQL service, leveraging whatever is in the machine learning. So kind of an implicit element in here, which is the computing, which is not there. And by the way, whatever you come to create here in the Machine Learning Studio could also be used in Power BI when analyzing data on the fly, right? That would also be possible. The point in here is when you are looking into AI and AI connected to your data, you are presented with two options. Sorry, presented with two options. One, predefined machine learning statistical models, and the ones you come to create. That's the second option. Here's another architecture. This is kind of a smaller one, right? You got a smaller icons here. I'm not sure if you can really read them, but you see the same some of the same actors in here. When you look around here, you see here that you have application. Can you still see my screen? Teams just popped up here, weird.
Yes, I see it.
All right, cool, okay. Thank you. So you see here the cognitive service going on in here, right? And Databricks is leveraging the cognitive services, which is interesting. You know, you can do that, no problem. You have data coming from your sources, whatever sources you are, streaming sources or regular relational services. And you have some, this is the compute I was talking about that was missing the previous slide in between machine learning and MySQL, for instance. So Databricks is the elected compute services here to get this data processed by the REST API. And then you get the data moving on. What you don't see here in this architecture is the machine learning itself, right? I'm still using AI. This architecture still suggests you to use AI, and the AI is here on the cognitive service, but not your custom models, not something you come to create, right? Or your business come to create, your data scientists come to create. It's just something that Microsoft offers and gets you up and running super fast. You're going to see in other approaches that what is my mouse here? You're going to see other approaches. You're going to see a lot of machine learning happening here in the lake. Try to do inferences and predictions, regressions, whatever you want to call it, here in the lake. So this one kind of doesn't do that, but it just shows you that you do need compute connected to the stream of data, so we can leverage AI, right, from Azure. And this is the whole point, right? This is the where you should start with when you work with AI into the data platform in Azure. What's the point? Am I going to use pre-packed models, or am I going to develop, or is my business going to develop custom models in order to process our data? And depending the way you go, you're going to end up in one of these two options in here. And these options in here is exactly what you have in Azure. You're going to find in Azure, oh, where's my cursor in here? There we go. What you're going to find in Azure is this one here, machine learning, or the cognitive service, as you have seen in the previous slides, right? Two designs before, the two architecture designs before. So one thing to learn out of the bat is when you say AI, oh, we're going to have AI into my data platform solution or into my application, the new system we're releasing. Well, AI is like kind of an umbrella term, right? It doesn't really pinpoint to a particular implementation. And in Azure, you have two possible implementations of AI. One, again, repeating, one is the pre-packed services and pre-packed statistical models to analyze your data that are in the cognitive service. And the other one is the one you come to create and you come to deploy and is specific to your business. And that's in the machine learning, right? It's the all the way to the top there, the other side there is the machine learning. So both of them can be leveraged on the data platform. You can call these guys from data platform from multiple places. Like from Power BI, for instance, Power BI service, you can create a report that has a Python script inside Power BI. You do have actually, I'm going to pop up Power BI in a few. You're going to see that you have a place in there where you can add Python scripts, and you can run Python libraries using models that be already trained in order to analyze your data and give great reports and great whatever kind of renderization you need to present your data to your report consumers. So you can get both of these guys here in one place or the other into the data platform and leverage your models, leverage the training of your models. But before we get there, and I will get there by the end of this session, I want to make sure you understand this step that exists before you can leverage AI, right? Which is the model training. So when you do cognitive service, the models are pretty much already trained, and you can, in a way, customize their training, right? For instance, there is a vision API there in the cognitive service, And if you upload a picture of, you probably have seen this on the web, it's very common, all Microsoft presentations to show that. If you upload a picture of a celebrity, they have already trained their cognitive service with pictures of thousands of celebrities. So it can recognize that picture, right? It tells you the person's name, what is wearing and things like that. So it's pre-trained. But if you're creating your own business, and let's say you're creating a hardware shop, people bring their pieces of hardware, whatever it is, to fix, and you want to take pictures of those things, and those are your specific to your business, you have to train the model with your own pictures, right? Whatever you are registering your system, so you can do your evaluations or ask the system to do your evaluations. So cognitive service will have some support for that. Actually, in the Power Platform, it's made super easy to do that. And the Power Platform leverages cognitive service as well. When we go there into Flow, I think they changed the name. I don't know the names of that anymore. But if you go there, you're going to find this. When you are really in need of something that is specific to your business and you don't find much support in predefined packages, is when you go into the machine learning. And to get into the machine learning, I want to show you, do this demo here for you. So let me change the camera here a little bit so don't get my head cut out of my neck or the screen. And I will get out of the way, get down here. That should work better. Something showing up there on the screen. All right. And let's go to the browser. So how does that work, Armando? Let me show you. And this is probably this guy. Yep, let's go here. Too many windows open. This is the guy. All right. So people told me already that the dark mode doesn't work well for presentations. Let me get it brighter again and get these fonts a little bigger. And let me show you around what I have created here for our session now. So as you can see, I do have here a machine learning workspace, right? That's one of the resources I've created for this session. Let me get here to the resource groups and get to SQL.Saturday.LA 2021 so I can filter better what guys can see. So here we go, right? We have here a machine learning. I did not create a cognitive service for this session because cognitive service goes more into development, right? It's source code type, it's all API calls. It really doesn't apply that much to us in the data platform. But just for you to have a reference, if you go here into the marketplace and you go into creating stuff, you're gonna see here cognitive. What is it? Cognitive. Right there, cognitive service, right? This guy here. And this is all about API calls, right? If you're a .NET developer, Java developer, whatever language you do, Python, you create these things in here, and then you get into the documentation and you start making calls and can create robots. I mean, those chat bots, right? Not robots, but chat bots. And it's a collection of APIs there are in there with a bunch of resources. For our specific, like I said, for our specific one, the life cycle of getting your model into the data, it's somewhat extended because what you need to do before you get your data analyzed is creating a model and training it. So, of course, this is a completely different subject. It's very extent, right? It's super, super vast, super wide. And here I'm just gonna present to you some of the specifics of this model training and give you some direction so you can try this on your own later. And here we go, right? When you create a service, and this goes a lot in a lot of Microsoft data platform elements. You create the service in the portal, but it seems to being given this secondary environment that's either called a studio or a workspace. So through Azure Portal, you manage the service, but you don't really leverage the service. You don't really customize or interact with the service. In order to interact with the service, you have to launch either this workspace or the studio, whatever they want to call it. And here's a big deal, because if you have, if you as a data professional or your data scientists or data engineers need to go in there and do stuff, they don't need permission in the Azure portal. They just need permission in the studio. And you can give the studio URL to people as you give them permissions, right? You come in here and give them permissions, and then they can work on the models. They can do whatever they want to do there without having to touch the portal. You don't have to give them permissions in the portal. It's very important for development life cycles and for people to do experimentation, right? So important for you as a data platform person to be aware of and know that you really don't need to get into Azure for those things, just the studio. This is not the studio that I want to see. This is the studio I want to see. So this, here we are into Machine Learning Studio. So when I already kind of ran through some of the steps in here to make this ready for this presentation, and also kind of save money. I was watching the previous sessions and putting this environment together. So what we have in here is a collection of elements that will, at the very, very end, will create a trained model. And here's the point again, right? The idea of the trained model. So if I go here, for instance, into the designer, designer is a very particular way into the Microsoft environment to create models, train them in a very low code to no code environment. So if I come in here, like you see, there is a collection of samples in here. I picked one of these guys, which was the regression automobile price prediction. I think it was this one here that I picked up. And when you click in here, this is what I need you to grasp from here, right? Not you as a data professional, but a data scientist, someone that analyzes the data and tries to get the statistical elements out of the data so we can predict how things will behave. They can come in here and without any knowledge of any programming language, they can come into the studio in here and define the data that's coming in, and you as a data professional may help with that because you're going to point to data sets that are coming in. See, this one should have created data set in here. No, it's hooking up to an external one. So there is, let me go back there. There is a data set here that's being used, the automobile price data. So there is some place where they're connect and get that data from. And all the steps under that, there is this data cleansing. So it looks like an ETL at some point, because they're doing data cleansing and they're doing data formatting. So you do have some data profiling, data ETL that can happen here. It's a very powerful environment to do data profiling. But the real deal happens over here. So you see this, the data split, like we have your data coming in and you're gonna use that many portion, right? That slice of it, that large of a slice of it, to train the model, and whatever is left out is going to be to check if the model can predict what was not presented to the model. So when it gets in here, like this model here that was chosen by the data scientist, they come in here and they do all the tuning up of the model. Actually, the model is over here, the linear model. They do all the tuning up of the model, the specifics of the model, and use Machine Learning Studio to get the model trained with the data, and then score if the model has achieved a good prediction level. And the prediction level is about 0, it was not able to predict anything, to 100% to predict everything. And the funny thing here, side note, is if you're training a model and the model got 100% prediction, it means you're wrong because models are not that good. So there is something that's biased in the model and is working well with your training set, the data set you're using for training, but more likely it's not going to work well in real world. But in any case, this is what data scientists would come and do. And this process here, this particular process I'm showing you, it does not show in these architectures. I'm gonna scroll back here a couple slides. Let me go back here a couple slides. For the first one first, this one. See, so that thing I have just shown you on the studio, it does not show up here. It's not here, right? You see this, the machine learning, but notice that the machine learning here is already connected to the data, there, doing the predictions, which means the model is already trained. And this is the portion that a lot of people miss when they are working with AI in the data platform or in Azure or any other cloud provider. If you are, regardless actually, if you're doing this guy here, right? Where's my cursor? Should be back here. This guy here or this guy here, there is some training that needs to take place so the statistical model can behave well with your particular business case, your particular subject. Way less training coming from here, unless if you're doing bots. Bots are, they're usually more, take more time to try to get bots going on. Chat bots and things like that, but very extensive type doing something that's not being shown in here on this slide, which is the side of training the model, which is this, right? Which is this. So make sure you understand that those architecture designs, sometimes they actually, all the ones I have seen, they kind of don't show this portion here. So this is one, and once this someone is happy, satisfied with the result of this, only after that is where and they get they test these things here by running experiments. And as you run experiments, this was the one I was showing you there. When they run these experiments in here, then they can see what are the results of these experiments. And as they are happy with these experiments, they end up creating endpoint services, which I have not created one because I'm not going to call through any API. So most of the things in here are either free or very low cost. And remember, when these things run, you need compute. So your compute is down here. And there are two types of computers in machine learning service, just for reference. One is for interactive use, which is the notebook I'm going to be showing in a second, which is this guy here. And this one here is for massive training. Once you have your notebook working with a small data set and you're happy with the results, then you give a very large data set and you can create compute clusters that can also be given to other services if you like. And these computer clusters will run over massive data. So yeah, so that's the idea of these things. The other way you can get models done, and usually people who come from outside Microsoft environment like rather this one better, is by writing notebooks. And this one here is one I got from GitHub. All of these things are available there. I'm going to give you the page in a second where I got this from GitHub. And this one here is to do another kind of a prediction, not the price prediction, but this one here is based on the New York City tax data set, the yellow cab. And this one here is trying to, is a model that will predict how much a ride would cost, right? What would be the fare for that one?
Armando?
Yes.
We're not seeing your presentation right now.
Oh, it went out?
Yeah, it went out.
Teams, you gotta love Teams. Here, and do this one again. And select my think again. How about now? Am I back?
Yes, now you're back. Thank you.
There we go. Yay. So from the beginning, from this topic again, right? We were looking into the designer, and again, this is kind of low code to no code, and super interesting for people that are getting started and they are new to machine learning, and they're not like very deep into the open source side of machine learning. When they are, they usually like, data scientists, they usually like working with environments like this, right, based on notebooks and common languages they use, like in this case here, Python. And again, I got this one here from a sample that Microsoft makes available, so I did not put one together by myself. And this one here, like I said, is to try to predict how much a taxi ride and a yellow cab ride in New York would cost. So this whole thing here just for perspective, so you can follow along. Of course, you're gonna, on your own time, you can dive deep into this and try these exercises yourself. But what this one is doing here by code is what this guy here is doing by Graph User Designer, right? This one, right? It's doing this exactly same thing. It's collecting the data. Actually, that one is generating the data itself. Would be doing some data cleansing and select some particular statistical model, set it up and train and score. And if it scores well, it will publish. So if I go back in here, you see, oh, not this one, no, this one. You see it going on in here, right? So it creates a data frame, which is the data set in there, creates the file in there, it's kind of the file in there, and preparing seed features. If you're not familiar with the terms in machine learning, features is what we would call columns on a table, right? So the data frame is the actual table, and features are the columns in the table. And just a side note here, in case you want to get introduced into these things, machine learning is all about asking one question and one question only, right? And you're looking for the answer for that one question and one question only. So this is a very specific case which depicts it very well. And the idea here is, what's the question? How much would the fare be, right? It's a very specific question. When you go into other models, is a piece of hardware broken? And then you have the specifics that will show you that through an image, for instance. And it's always about answering one question and one question only. So when you get to images, usually you have multiple questions, which means you have multiple models analyzing the same pictures to get the answers for every question. So when you get into this exercise here later on your own, if you decide to, you see that's very focused on that particular question, right? It's only that question and how much the fare will be. And as you can see here, see the training the model as a Python code. And once the model is trained, it's ready for use once it's published. So back to my slide. And again, if you have questions, please write down your questions on the chat window. We'll go back to them in a few when we are start wrapping up this one here. So I was in the demo slide, which is this one here. So that's how the machine learning element gets created, right? Gets ready. Let me reset my thing. And, oh, well. It doesn't want to reset my view. Look at that. There we go. Back off camera, back in camera. And let's go to the next one. So once the machine learning model is ready, it's time to get it available for our data services, right? Not just for the applications. Of course, applications will leverage those, but we want to get them available to our services, our data services. And here's the big deal. Remember that in order for the model to work with your data, you need compute. You gotta have some compute service involved. So like if you have the lake and you have your model, they will not mingle, right? You need compute in between. In order to get your model ready to analyze the data in your data lake, for instance, or in Azure SQL Synapse or something like that, you have to go into a deployment phase. And here's the point where some people also get lost, because they try to push the model straight out, and then they lost control of regular deployment phases, CI/CDs and things like that. So there is this particular service in here, which is open source, called Machine Learning ML Flow. And the idea of the ML Flow is to push the data, the model out after development. So all that environment I have shown you, it can be considered actually a development environment, right? You're getting the data model, so the data goes out. And once you get your, not the data, but the model rather. So you get your model, you train your model is cool. You register your model, like we have seen there in the Machine Learning Studio. And once it's in there, you start pushing it out to a point where it can be consumed, right? In order to be consumed, like I said, some compute must be hosting it. And the suggested model is to present, the suggested approach, I'd rather say, to use different term, the suggested approach is to get your model presented as a REST API. And that's what we have seen in both cases before, right? And this is one of the reasons I have this session together, because the REST API is the most traditional one, it's the common one, you can use that one. You're going to be built by the calls or by the hosting environment, whatever it is. But the thing with the machine learning flow to get into deployment environment as a container running on a container instance or in a Kubernetes environment, or even as a web app and with REST APIs just by itself, is that it's far from the data. And in my case, that I work a lot with data warehouses and data lakes, not the lake houses, it's terabytes of data. I work a lot with this kind of environment. Getting these calls as REST APIs, they don't work for me or for my customers, right, in their business case, because it just gets too slow, it's super slow. So one of the ways is doing this, and this is the other way. It's kind of the same way, same architecture, but kind of the other deployment. You see over here, that is referring to web service deploying machine learning solutions. So you train your model, you get your model out, and you get it there, and you call your model from interactive sites. So this is all valid, but really not really applicable to our environment. So to push it up to where I really want us to be is to understand that at the very end, let me get back here. At the very end, when you push it out as a machine learning model REST API endpoint, a better approach for you in the data platform in Azure is to get the model into the data engine, right? You want to push the model right into the data engine so it works natively within the data, embedded into the data engine, and process the data without network traffic, right? It's your compute becomes the actual data engine, right? And Microsoft supports that on multiple data services. One of them is Synapse, is the one I'm going to demo here for you. So the point here I need you to get clear in your head is when the data model is ready, if you go to all the architectures we have seen before, they are making REST API calls to endpoint on a virtualization compute service somewhere. The best way to work with that on massive amount of data, large amount of data, is to get the model into SQL Server. And how do you do that? Let me skip that demo here, get right in here. So how you move away from this and get into that one is by you doing this, right? So when you create a machine learning model, you can deploy in, there are a few formats in there you can deploy your statistical model. Microsoft has elected this particular approach here called Onyx, and there is a website, onyx.io, and what it does is it allows you to get your trained model, what we have just presented to you. It allows you to get a trained model, enveloped into a package that can run on any environment that supports the Onyx runtime. And this is the trick. That's the whole thing, the whole secret of this session here. Once you get your machine learning model from whatever platform, it doesn't have to be Microsoft. It doesn't have to be Machine Learning Studio. I just happen to use that one for as a base for the demonstration. But it can be from any other environment, from any other vendor, as long as you get the model, the trained model published as an Onyx. You can embed that model anywhere where the Onyx runtime is available. So you can get to cameras, you can get to drones, you can get to cell phones, you can get to any device that supports the Onyx runtime. And interesting enough, like I said, in many SQL services in Azure, we do have that. One of the ones we have is the Synapse SQL service. So that's where I'm going to jump in right now. Let me show you that. And of course, I need to get out of the way. I have done some changes here on my little studio, my home office and studio home. And my screen here is not well positioned. That's why I'm kind of caving here. It will get better for
Data.SQL.Saturday.LA 2022, but I think we'll be there in person, hopefully. Let me get this guy back in here. So here we are. You see, we trained the model. That's where we left over before. Let me get it a little bigger here so you can see that. Minimize this one. So we trained the model. The model is ready to go into production. And in order to get that model really embedded into the data platform from whatever Microsoft service we are looking into, we get to convert that model into the Onyx format. So once the model is trained, is coming down here in the pipeline of this notebook, this is pretty much what is needed to get the model created. So the model that was trained that predicts how much a fare would be, after this one here, it's going to be published as an Onyx model. And once it's published, once it's created, you have to register like we have seen before and publish. So it will show up here into my models. So here's my model. Yeah, then you're texting here. You got two versions of it. I did some changes in there. So I got two versions of it. And this guy is ready to be embedded into, for instance, into Synapse. So if I go back here into Synapse, I created here a simple, sorry, a simple database in here. There is pretty much no table in here. There is only one, here, workspace. Here's the database. By the way, this is supported on a dedicated SQL pool only. It's not still available for serverless SQL pool. And it can also be used on the Spark pool too. But so here's a database, right? The database I created, and here's a table that was, here's the result of the table I've imported from the sample file that's in there. So the point here is I have this table. This is a collection of data that's in there for testing to see how the model behaviors. In a real world environment, I wouldn't have the fair amount, but the idea is to run this one here and see the prediction and see how close the prediction gets to this fair amount. So in order to do that, I need to connect my data service, in this case Synapse, to the Machine Learning Studio. And again, I need compute, remember? I need compute to get the model to work with my data. In this case, the compute will be a Synapse itself. So I don't have to pay extra VMs or extra container services to run that model. Synapse will grab that Onyx model, bring into itself, and run the model internally. And the way we do that is by connecting these two guys together. So here I have linked services in Synapse. And by the way, I'm doing this example here, this demo in Synapse. So if you go in SQL Server, if you go Azure SQL DB or any other database, you just have to figure out how you set up these things over there, how you embed the Onyx model over there. In this case here, we come here into linked services. And you say, you know what? I do have a machine learning. Oops, not this one, this one. I do have a machine learning environment I want to connect with and leverage some models in there. So give it some name, and this is you see the name over here. Where here? See the name over here, right? I think. So now I can zoom in, and you guys can see that. Oops. There we go, right? So this is my machine learning model here. We've got some casing making the difference in there, and that's what shows up in here. That's the machine learning. Unfortunately, my demo will fail or will come short in here because for some reason, the environment I created for this demo earlier today is not bringing in the managed system identity, only the server principal. And the Synapse workspace, it runs on a MSI, on the managed system identity. So for some reason, this thing is not giving what's supposed to be given here for me, which is the authentication elements for the workspace. But it will work sometime later. More likely, I will find that out later. Unfortunately, it did not came back to us. But let's keep going here. and see how that would work if that was successful. So discard this one here. When I go back here into the database, into the data, and look here into the data set, I want to have my Onyx model created or associated with the processing data in there. One of this particular approach here, I could just right click on this guy, and there would be an option here that's not showing because that screen failed, which is analyzing with your machine learning model. So by selecting that one and pointing to the model that's been published in machine learning, the Onyx model would be brought into Synapse, and from Synapse, it would analyze whatever the data there. Just have to point to the columns, right? They call it the features. Point it to the columns and have the prediction running using the compute that is assigned to the Synapse SQL pool. With a very important caveat here: when it goes like this, the data is not traversing back and forth into machine learning environment and Synapse. So there is no service communication. Everything's running within Synapse. There is another approach to do this is if the Onyx model was created not in Machine Learning Studio, but you do actually have an Onyx model file. You can also import that Onyx model file into Synapse SQL. In this case, we're using Synapse SQL. Right, so yeah, unfortunately, my identity did not show up in there. It was supposed to show, it did not show. So I'm gonna kind of cut short here. You're not gonna see the model actually predicting anything this time around. But look up for me later on LinkedIn, and I will probably have that working for us there sometime later. So to wrap this up, and then going to the thank yous and the questions. To wrap this up is, if you really wanted to leverage machine learning and your specific models, you're more likely not going to use cognitive services. Remember, cognitive services are always REST APIs that work outside as a service out there in Azure. And therefore, you need that service communication and authentication. For massive or large data processing through machine learning, especially if you're doing data lake and doing Databricks and these things, or Azure Synapse, what you want to do is to get your model exported as Onyx and embedded into, again, Synapse, Databricks, or Spark SQL pool, someplace like that, where the compute of those services will be processing the data, and then you get your data super fast. The whole point, in summary, is to get your trained custom models export as Onyx and imported into the data platforms, including Power BI. So with that, I thank you. I hope you have learned something new from this session. And Laurie, do we have any questions there? I don't see the chat window here.
There's one. What is Bellow the FPGA? I'm not sure what that means.
What is what?
Yeah, what is Bellow the FPGA?
What is the below? What
below,
is?
Oh, below. That's probably the FPGA.
Ooh, I have no idea what. Who is that? This is Saba. Saba, if you want to come up out of mute and use the microphone and help me out, what you're asking about, that would be great. I don't remember showing SF.
Yeah, sorry about that. That was for a specific slide, and
which slide?
You were showing where this Onyx platform was deploying, and there was GPU, CPU, FPGA, and NPU. That was below it.
This guy here. Okay, now I see. You're talking about this one here, right? Yeah.
The one below. The NPU, probably it's a neural processor unit, I guess. Probably
exactly. Yeah.
Specialized.
These are all kind of a specific compute capacities that you can find. Some of them you can find in Azure. Some of them are very specific hardware, and they have Onyx runtimes for those platforms.
Thank you.
Sure.
Was that the only one?
Yeah. That was the only question.
I think I put everybody to sleep.
No, not at all.
Or
everybody
stayed.
Happy. Yeah.
Anyways, thank you so much for having me in the session. I always enjoy to be on SQL Saturday LA, being there for all of them, and hopefully next year we'll be together. Will it be on the same university there?
I don't know, to be honest, but yes, we certainly do hope to be in person, which would be great.
All right.
Yeah.
So with that, I send it back to you, Carrie. Thank you again for helping me out here.
Laurie.
Laurie, sorry, Laurie.
Okay, Armando.
Carrie's my co-worker, you see?
Oh, okay. No problem. All right. Thank you very much.